Task 8 is asking us to, the question is how many solutions? So we're supposed to consider this equation right now, and then if possible, find a second linear equation to create a system of equations that has, and they've listed 4 things, right? Create an equation that has exactly 1 solution with this, create one that has 2 solutions, one that has no solutions, and one that has infinitely many. So right off the bat, since we're talking about linear equations, and just thinking about them graph-wise, if this is a linear equation and that's a linear equation, we could have 1 solution. We could have no solutions where they never cross. We could have, here's a line and then it turns out another line right on top of it. So that would be infinitely many. But there's no way to have something with exactly 2 solutions if they're both linear. We'd need some kind of curving back around like this to end up with 2 solutions. So we know that this is not possible. So we can right off the bat just say it's not possible to have 2 linear equations with 2 solutions, exactly 2. So then the trick is here to create systems here that have 1 solution, 2 solutions, or infinitely many. So this would be like 1 right on top of each other. So let's see. Let's start with exactly 1 solution. And I think that a lot of folks understand this better when thinking about graphing it. So I'm going to go ahead and put this in slope-intercept form. So 5x minus 2y equals 3. If I subtract 5x from both sides, I have negative 2y equals 3 minus 5x, and then divide by negative 2 on both sides. Y equals negative 1.5 plus negative divided by negative is a positive 5 halves x. And I'm leaving this a fraction because it's easier to think of slope as rise over run. I'm leaving this as a decimal because it's easier to think of y-intercept on a particular point on the graph. So this graph would go down to negative 1.5 would start there, right? But then we would go up, let's see, 5, 2, 3, 4, 5, and over 2 to graph this line. So if I want to find a line that has exactly 1 solution with it, I just need any line at all that has a different slope from this line. Any line. It doesn't matter what the y-intercept is at all. As long as I have a different slope, I can create something with exactly 1 solution. So I'm going to say y equals 5 plus 3x, and I know that this is going to have exactly 1 solution. 1, 2, 3, 4, 5. And then I would need to go up 3 and over 1. So this line it would take a while for the 2 to meet way up here, but I know because they have a different slope, they will eventually meet. So you create your own line with a different slope. As long as it has a different slope, it's going to be a different kind of line. No solutions. Now for a no solution situation, I need to have the same exact slope. I need to create a parallel line, but I need to also have a different y-intercept. So it doesn't matter where my y-intercept is as long as it's not exactly at negative 1.5. So say I put it at 2 and keep the slope at 5 over 2, then I have parallel lines, right? So no solutions. Y equals 2 plus 5 halves x is going to have no solutions at all. And infinitely many solutions, actually this is exactly an example of if I were to graph y equals negative 1.5 plus 5 halves x, these 2 equations look different, but in fact they are right. This line and this line are equivalent. They're right on top of each other. So this line and this line have infinitely many solutions, right? There are algebraic ways to also create these, and we've gone over some of that in class, but this is a perfectly acceptable way to think of it and has the visual to go along with it. I'm not going to answer the bonus question, but if you do, then it's a bonus.